Hello friends, in this session we are going to see the static control flow of a program with inheritance, right? So you have, assume you have a class A, and a class is having some variables like this, say int x is 10 and one static block. Okay, int x is also static, so this is static, and you have a static block. I'll take only one block and I'll write here a SOP statement of static initialization block 1, and I'll take it should print here, say SOP statement of x, and I'll print SOP statement of y. I cannot print here, so I'll write here, actually it is a dot y, right? And this block is also static, so static, and I'll have a static variable, static int y is equal to, say, some value, so it is 20, right? So this is one class A and class B. Class B extends A, right? Class B extends A, and B is also having some static variables, say static int I is equal to, say, 99, and one static block is SOP statement of static initialization block in B class, right? Then it has to print the I value and it has to print the j value. J value is later, so I cannot directly access. I'll write b dot j. Then you have a j here, static int j is equal to, say, 88, right? So this is the class B. Now you have another class, say you have class test here, class test, and in that you have public static void and main method, right? Main method. And in this you are accessing this B. Okay, B class you have to use. So what I'll do here is I'll take let's create an object of B. B1 is, or not object, I'll just access a static variable of B. Say it is SOP statement of B dot I and SOP statement of B dot J, right? B dot J. And also we'll access this x and y. X and y is inherited to B, right? So that also I'll try to access the SOP statement of B dot x and SOP statement of B dot y, right? So this is the main method in class test, and here we'll write the output, right? And when you will write here Java and test and press enter, then JVM has to start. At the time of starting the JVM, okay, JVM is, say it is JVM is this, and JVM memory allocates like this, allocates the memory, and it is, say, this, right? And it is this. So this is method area, so this is method area, stack and heap memory, right? So when we will write here test, and the test is loading, suppose this is test loaded, this is test, and inside the test main method is there, and main method starts execution. So this is main here, and main starts execution, right? Now control comes into the next statement here, and it is to print b dot I. But where is B? B is not loaded yet. So what JVM will do is JVM will search the B class is available in the method area or not. It is not available, so JVM goes to your workspace and it verifies where is B, right? Where is B, and say B is this, B is found, and then B class has to be loaded. But we have already discussed somewhere how many ways a class can be loaded. So if you have not watched that video, watch that first, how many ways a class can be loaded. And there we have discussed, before loading any subclass, the superclass must be loaded, right? Superclass must be loaded. So before loading class B, here actually main method is asking for B class, but when JVM will try to load the class B, B is having a superclass, that is A. So JVM will try to load superclass first, A, and this is class A. So here it will try to load, JVM is going to load class A first, right? Class A first. Now at the time of loading the class again, JVM goes through the entire class and it verifies what are the static members available. So in that, one X, one static block, and another Y static variable, right? 3. So first all these static members identification is done, and memory for X is also initialized, allocated and initialized with 0, and Y is allocated, initialized with 0, right? And in the previous session we have seen how JVM finds out the static members and how allocates the memory and what happens, all these things you have seen. So at the time of loading the class, first JVM has to complete the complete loading of class A first, and then it has to go to the B class. But here actually you are asking for class B to load. But what JVM will do, before loading class B, it has to load class A. So at the time of loading class A, JVM is doing all these steps again, and JVM go through the class and it finds what are the static members available, and all the static member identification is done, and allocates the memory for X and allocates the memory for Y, and initialize that with the default value, right? Once that is over, so this is class initialization, and these two variables are now you cannot use directly, because these variables are not readable now directly, right? So JVM goes through the next step, and again it goes through the entire class in top to bottom approach, and at that time JVM initializes the static variable with the hard-coded value if available. So X will be initialized with 10 and it becomes 10, and it also executes the static block along with this initialization and in the same order how that appears in the source file. So first X got the memory, X got the value which is 10, and 10 is initialized to X. Now next is, it is a static block, so JVM has to execute the static block. Again block execution is top to bottom approach. So this control is at this point, and it prints here instance initialization block in A. Actually, okay, it is A, right? It is A. Then control comes to the next, and it has to access the value of X. X is 10 already initialized, so this gives here 10. Now it has to come at this point, and it has to access the value of Y, but Y cannot read directly at that point, so I have used class name to read it, otherwise you will get a illegal fraud reference here. So I have used class name, right, a.y. Now at that time Y value is 0, so it prints here 0. So second static block execution is also over, and then control goes to the next, and Y initialized with 20, right, 20. So this class A loading is over. Once the A class loading is over, then it tries to load class B. Now when it is loading class B in the method area, again it goes through the same steps, and B class should be loaded in the same way, right? So again JVM identifies what are the static members available. So it has one static variable, it has one static block, it has another static variable, right? So at that point it will identify all the static members and allocates the memory for all the static variables. So this is first time 0, and then you have J also, and J also should be first time 0, right? Now again JVM goes through the entire class and initializes the hard-coded values to the static variable if available, and executes the static block also in the same order how that appears in the source file. So first I gets 99 initialized, and then it comes into this static block, and a static block is having the first statement, it prints here static initialization block in B, and I should be accessed. I value is at that time initialized with 99, so I value gets 99, right? Then it has to access J cannot be accessed directly at that point, so I am accessing with the class name. If you try to access directly, it gives here illegal forward reference, so I am accessing with the class name, and it gives here J value at that point it is 0, so it prints 0. Then control comes at the next point, and J should be initialized with 88, so this value is now 88, right? And this is done. So B class loading is also over. So class A is loaded first, and then class B is loaded, and after that control comes into the main block here, and B dot I. At that point B dot I is actually you are accessing B dot I, and B dot I is 99, so it prints here again 99. And B dot J, what is B dot J? B dot J, when you will say again B dot J, again it is not going to load the class, because B class is already loaded at the first point, at this point, right? B class is already loaded. So when you say here B dot J value is 88, so it prints here 88. And B dot X, when you will say B dot X, in B class X is not available, but X is available in super class A, where X is available, but this X is inherited to B, so B class can use this X from A also, so it accesses this X, and the X value is 10. And B dot Y is also inherited, so Y value is 20, right? So this is the static control flow of a class with inheritance relationship. Now suppose class A is having some other super classes, right? And your asset is multi-level inheritance, and A class is also having some other super classes. So in that case, when you are calling B dot I, first JVM will try to load the B class, but B class is having a super class A, so it has to load A class. And in that case, if A class is also having another super class, then that class will try to load by JVM first, then it loads class A, and then it loads class B. So important point you have to remember is, in all these classes, static control flow is doing once, and once that one class completes the complete static control flow, then the control goes to the next class, and that class again does the same thing to load the class. But when you are requesting for a subclass, this point you have to remember, notice very clearly, when you are requesting for a subclass, that before loading the subclass, superclass should be loaded if the superclass was not loaded before. So in this case the output is this, and it is working in this way. But assume if I do a little bit changes in this program, if I say before saying B dot I, I'll write here on a suppose statement of A dot X. If I do like this, then what will happen when JVM starts executing the main method? First statement is A dot X, and when it will come here A dot X, at that point it will search that A class is loaded or not. At that point A class was not loaded, so JVM will load class A. And when A class is loading, it is not going to load class B, because B is the subclass. When you are loading a subclass, before loading subclass, superclass must be loaded. But when you are loading a superclass, subclass is not going to be loaded. But now here what I am doing is, I am saying A dot X. At that point any of these two classes are not loaded, suppose, then A class will be loaded first. Only A class is going to be loaded, and A dot X will be accessed, right? And the complete control flow, again static control flow in class A will be done, and class will be loaded. Now assume the next step is B dot I. Now at that time B class was not loaded, so what JVM will do is, JVM will try to load class B, but B class is having extends A, superclass is there A, but A class was already loaded at this point. Now will it load class A again? It is not going to load class again. Class A was already loaded. So any class is going to be loaded inside the JVM only once, for the first time when the class is going to be used. If you are directly trying to load a subclass, and before that superclass was not loaded, then only the superclass will be loaded first, and then the subclass is going to be loaded. But if the superclass was already loaded, and when then you are trying to load the subclass, at that time superclass is not going to be loaded again, and the static control flow will not be done here, and directly it is going to load the subclass because the superclass was already loaded. Now let's see that with an example in Eclipse. So it is, suppose you have a class A, and A class is having some members like say int x, and which is 10, and one static block, and this x also should be actually static, right? Static. Now in this I'm writing it is say static initialization block in A, and then I'll try to access x, and I'll try to access y, but y cannot access directly because it is not declared at that point, so it is a dot y, and then I'll write here this is static int y, and it is 20, right? So this is class A. Class B extends A, and in this also you have static int I, and I is equal to say 99, and you have a static block, and it is static initialization block in B class, and this also has to access say I directly, and j should be with b dot j, right? And now you declare here static int j is equal to say some 88, right? This is class A and class B. Now if I write in the main method say something like this, say it is b dot I and b dot j and b dot x and b dot y, right? So all these members. Now when I will execute this, when you will run this program, b dot I should be accessed first, b dot I. But before using this b dot I, B class is going to be loaded, right? B class is to be loaded. Before loading B class, JVM will check, okay, it is having a superclass or not. It has a superclass A. So A class should be loaded first, because till that time A class was not loaded. So at the time of loading A class, all the static members identification, so all three is available, okay, and X gets the memory initialized with 0, Y gets the memory initialized with 0. Right, again in the next stage, next run, JVM initializes the 10 to X and executes the static block, so it gives the output SIB in A. X value is already initialized at that point, so it is 10, it prints here 10. And Y is not got any value till that time, it got the default value, so here it gives 0. So at this point you are going to get the output is like this. So the output should be first when you will say b dot I, and B class should be loaded, but before loading B class, A should be loaded. At the time of loading A class, X memory got allocated, and X got the value 0 first time, and then in next it is 10. And Y also already initialized at that time, but Y value is 0. So now when control is at a static block, it prints here a static initialization block of A, and X value by that time is 10, Y value is 0 at that point, right? And then control comes at this point and initializes that Y with 20. That is done. Class A loading is over. Now B class A loading is over. Now B class should be loaded. At the time of loading B class, again I memory get allocated 0, J allocated, that is 0. Then in the next, again I is initialized with 99, and static block should be executed, so it will print here static initialization block in B, and I value is at that time 99, P is 0, then J is initialized with 88, right? But J is not accessed, right? Now control comes back into this. Class loading is over. Now it is b dot I. At that time it will be 10, and then it comes here b dot j will be at that time, sorry, it is not 10, it is 99, and J is at that time 88, and B dot X it is 10, and B dot Y it is 20, right? So this should be the output if I run this program. right? Now run this and see the output. The output is this, right? So first static block A, it is in class A, static block A in class A, right? This one. Then you have 10 is because at that time x was already initialized, so x value got 10, and y value is still not got, it is having the default value at that point, so it is giving here 0. After executing that 0, and y value gets here as 20, then it comes into class B, and B class I memory is already allocated, it comes into execution, and SIB of B class is printed here. Then it comes into I value at that time is initialized already, so I value is 99, but J value is not initialized, so J got 0, right? So both the class loading is over. Now it comes into B.I. B.I is 99, B.J is 88, and B.X is 10, and B.Y is 20, right? So this is the static control flow of a Java program with inheritance. Thanks for watching my video. Please subscribe for more videos.